So in this video, I'll be discussing what is reliability and how reliability is going to work out in the system, how to check the reliability of different components produced. So here a system is a collection of components, subsystems and assemblies arranged in a specific design in order to achieve desired function with the acceptable performance and reliability. The type of components, their qualities, their quantities, the way in which they are set inside the system have direct effect on system reliability. So malfunctioning of a component or part may lead to breakdown of the whole system in few cases. In few cases. So here reliability tells about what will be the operating range and what time it is going to fail. So this necessitates a cautious study of components failures and failure modes, their functions and also their failure models. So what are the failures and failure modes? So failure is defined as non-conformance of some defined performance criterion. Some products have well-defined failures while others do not. So here if you take some of the examples here, it is defined with the electric bulbs and switches have well distinct failures. Either they are working or non-working. Such products are also known as two-stage products. Some products like voltage stabilizers, resistors, etc. work within the range. The output voltage of stabilizer may lie within the limits. When the output voltage across the limits crosses these limits only, the device is supposed to have failed. For evaluating the quantitative reliability of a device, the concept of failure and the details has to be used. Several years of knowledge of failure data of different devices have been revealed that based on the nature of failure. So when you take a large collection of elements, when they are in operation, it is possible there are a huge number of failures initially, which are called as initial failure or inferred mortality. This initial failure are due to the production defects such as weak parts, poor fit, poor installation, bad assembly, etc. This period is known as burn-in or debugging period, as the malfunctioning unit are eliminated in the initial failure period. So here this failure and failure modes, what it tells is some of the components may fail at the early stage because of non-conformance of the standards or not assembled properly. So further it will be operating normally if it is corrected, or it may fail early also if it is not corrected. So like this that will be there. Then it comes the operating period, and afterwards, after operating for a certain time, the life of the component it is going to fail. So in the bar top curve here, it shows the failure rate versus the time taken. So initially there will be the failure. What happens? That is known as infamous early failure. This it can be corrected initially. When it is sent back to the company, they are going to correct it. So once those things are corrected, that comes the time between T1 and T2, that is known as useful life, where operating period it will be very good. So there won't be any failures at that stage. So after the T2 time, we can see that is the third zone known as the wear out time. In the wear out time, we can replace some of the parts where it has worn, but completely it starts failing because all the parts all are produced. It is going to lose its life after time to the products is changed with the pre-tested product. So if some products or if some parts which are added in the system, if it has still some life, it will start wearing out gradually with respect to time. So this is known as bar-top curve. So in this when you talk of reliability, bar-top curve output is very important, and this has to be kept in mind.